So let's go ahead and work on naming molecular compounds. Again, molecular compounds are compounds that contain nonmetals. So your nonmetal species. These are not polyatomics combined together or polyatomic. So like ammonium with something that's a nonmetal anion. It's just your nonmetals. We are only going to be naming binary compounds, not ternary, meaning only 2 elements, not 3. You also need to know the stable elemental forms of elements in their monatomic, diatomic, and polyatomic forms. There are 7 elements that exist as diatomics, 4 elements that exist as polyatomics, and you are responsible for knowing which is which. So again, our naming chart, now we are following down the molecular side. So we've gone down the ionic side, practiced that in modules B or C and D. We are now going this direction and naming under the molecular side. Molecular is pretty straightforward, nonmetals only. We're using prefixes to actually describe how many of each species we have. Here, this will be on the next slide as well, but here's a nice representation to show you how you can recognize your diatomics and your polyatomics. We have 7 elements that want to be diatomics, meaning that it's 2 atoms of the same element bonded together. They do this for stability reasons. They share their electrons. They reach their noble gas electron configuration, which we'll talk about in a later chapter, specifically in modules 9. But here is a great way to memorize them. Again, there are 7 diatomics. Some people remember this term Bringelhoff. That's what some people have memorized as a mnemonic. Some people remember have no fear of ice cold beer. That's fine as well. What I do is I remember that I have 7 of them. It is starting at the number 7 for atomic number, and I form a 7. That incorporates 6 of my 7 elements, and then I have to remember hydrogen over here. So again, if you want to remember have no fear of ice cold beer. That is for H2, N2, F2, O2, I2, Cl2, and Br2. That is another way of remembering it, but you do have to know your 7 diatomics. So again, I had it memorized by atomic number 7 because I knew there were 7 of them, and it formed a 7, so 3 across, 4 down, and then I'd have to add hydrogen to it. But some people like the have no fear of ice cold beer a little bit better. The other 4 form polyatomics. And one is not actually marked on your sheet here, but it is this one right here. Arsenic actually does this as well. Phosphorus and arsenic, both of these species, like to form polyatomics where they have 4 of them bonded together. Sulfur and selenium like to form compounds where they have 8 of them bonded together. You are responsible for all of these. So diatomics, again, you do need to memorize these. H2, O2, Cl2, I2, N2, F2, Br2. I don't care how you do it, you need to have them memorized. Now, another thing I want to be just kind of specific about, actually, let me go back to this slide because it makes more sense here. When I say things, you need to be careful with naming these substances. I'm going to use hydrogen as an example, but the same thing could be applied to the other diatomics or polyatomics. When I just say H, a single H is hydrogen. We could also call this atomic hydrogen. Saying atomic hydrogen emphasizes the fact that it is one single atom of hydrogen. If I say H2, I also call this hydrogen. So how am I distinguishing between these two? By the context of the question. I do call this hydrogen. I could call it diatomic hydrogen. I could call it molecular hydrogen because it's forming a molecule. Sometimes you'll hear it called dihydrogen. And you will definitely hear it called hydrogen gas because it exists as a gas at room temperature. All of these represent H2. If I say hydrogen reacts in a reaction, I actually mean H2. So you have to be careful on when do you mean H, when do you mean H2. And again, that comes from context of the question. If you see H plus, you can call this a hydrogen ion, just like how we name your metal ions, hydrogen ion. We're going to call it hydrogen ion. It's lost, but because it's lost its one electron, all it has left in its nucleus is a proton. We also call this a proton. And in second semester, we're going to use this in place of the hydronium ion. In acid-base chemistry. Lastly, you could have H minus, which we call hydride. See, the same things for the other things here, other elements listed here, other diatomics, polyatomics. When I say oxygen, if I'm talking about reactions, I'm talking about O2, but saying oxygen could also mean just a single oxygen atom. I can say oxide for O2 minus. So again, O2 minus becomes oxide. Cl minus becomes chloride. But chlorine, Cl2. Atomic chlorine, Cl. So please be careful, and again, context of the question. Big thing to emphasize again, molecular compounds consist of two non-metal elements. You will only have two in there. I apologize. I still need to fix this slide. I keep forgetting to fix this PowerPoint specifically so that it actually puts this together. 9 is Nona. What you do is you're going to name the first element listed with its regular name, the name that you have memorized off the periodic table. The more electronegative element is the one that gets an "ide" ending. We haven't learned electronegativity yet. That comes in chapter 9 or 10, but traditionally that will be the element that's listed second. Most often the element listed second in the formula is your more electronegative element. So the first element named regularly, the second element named with the ending of "ide." Because we can have a varying number of one specific element within a formula, we can have different combinations, such as CO versus CO2. We are going to use prefixes to describe how many we have of a specific element within the formula. If the first element listed only has one atom, no prefix is used. So for example, this, we say carbon dioxide. Using the prefix di to describe the two oxygens, but I don't have a prefix in front of carbon. I just wrote that in the wrong spot. I apologize. This is carbon dioxide. It's reading the wrong spot. Two oxygens. I don't put mono in front of carbon. But for CO, I write carbon monoxide. I am now emphasizing that I have one oxygen in this formula, but I'm not putting a prefix in front of the carbon because it's the first element listed. The first element listed does not have a prefix. It means there's only one of them. So for example, N2O5, I have 2 nitrogens, 5 oxygen. I call this dinitrogen pentoxide. SF6, I've got 1 sulfur, 6 fluorine. It would be sulfur hexafluoride. No mono in front of that sulfur. PCl5, I've got 1 phosphorus, so I'm going to say phosphorus, not monophosphorus, just phosphorus. And then 5 chlorines, pentachloride. Notice again, I am ending the names in "ide." And yes, it would be incorrect, and it would get marked wrong to put a mono in front of the phosphorus or a mono in front of that sulfur. We do not emphasize 1 if it is the first element listed, and it would be marked incorrect. The prefixes you need to know. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hepta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. Anything beyond that, you would be able to look up. I would not, at this point in this class, we don't require you past 10. When you're starting to put these together, sometimes you're going to drop the A's here. It depends on the question. So we can see here, like hexafluoride, pentachloride takes the whole thing. But sometimes, depending on the question, you won't always see all those letters there. It kind of, how we drop the letters and add the prefixes and the ending of the letter kind of goes within the element itself. And so we're going to see some practice on that. You're going to see some different things written. It just kind of comes from practice to know how to put these together properly. For the most part, though, your prefix will be listed as described. Let's go ahead and work some examples. I'm trying to go from name to formula first. I've got carbon and monoxide. Well, carbon is easy, right? That's just telling me carbon. Carbon is just elemental C. Mon, that stands for 1. Ox tells me oxygen, and I just tells me it's the second element in the species. So I've got 1 carbon, 1 oxygen. Carbon dioxide, I've got a carbon. Di tells me 2. Ox tells me oxygen. CO2. Dihydrogen monoxide. Di means 2. Hydrogen, element just written normal way. Monoxide. Mon means 1. Ox means oxygen. H2O. Boron trichloride. Boron, there's no prefix, so I've just got a B. Tri means 3, and chloro means chlorine. BCl3. Dinitrogen tetroxide. Notice here is where I have not written tetra oxide. I'm not going to put the 2 vowels next to each other. I'm going to drop that A and write tetroxide. Dinitrogen, 2 nitrogen. Tetra, T-E-T-R-A, even though I've dropped the A, tetra, stands for 4. Oxide stands for oxygen. N2O4. And sulfur hexafluoride, we did see on the previous slide along with the 2 examples I've used already for carbon, but sulfur, just an S, hexa, 6, and fluor here means fluorine, SF6. What if I want to go the other direction? What if I want to give the name from the formula? Well, let's look at this. We've got P, which means phosphorus. Five chlorines. 5 is penta. Chlorine is chlor. And then instead of saying chlorine, I'm going to say chloride. Phosphorus pentachloride. CCl4, I've got a single one here, so I'm not going to write mono. I'm going to write carbon for the carbon. And then I have 4 chlorines. Tetra chloride. 1 carbon here, carbon. 2 sulfurs, 2 is di, sulf. Now I'm going to drop the part of sulfur and add ide. CO, again, C, single carbon. I have 1 oxygen here. I'm not just going to write carbon oxide. That is not correct. Even though it's the second element, I need to emphasize there's only 1 of them. And I'm going to write mon for mono, oxide. So I do not write mono oxide because I don't want the double vowels next to each other. I just drop 1 of them and let the O hold for both pieces. Carbon monoxide. XeF6, Xe is xenon. 6 fluorine. Hexafluoride. Now the HCl here does emphasize gas, and that's going to become important because in the very next module we're going to talk about naming acids. Acids are when we have molecular compounds like this dissolved into water. But because it is saying gas, that means it is a molecular compound. So H, hydrogen, Cl, just 1 of them, monochloride. SO2, 1 S, sulfur, 2 oxygens, dioxide. SO3, 1 S, sulfur, 3 oxygens, trioxide. So naming molecular compounds tends to be easier for students because they just remember the prefixes, and it's kind of faster and easier to do them than ionic compounds, but you do have to remember the naming conventions. You do have to keep them straight and be able to do them correctly depending on what kind of compound you have.